Hello everyone! We are Group 3, and we will present a real-life example of a company that applies strategic capacity management. Our presentation will cover capacity management in operations, capacity planning concepts, and service capacity planning based on journals relevant to the topic. The article, The Role of Plants in Manufacturing Networks, a Revisit and Extension, by Ching and Farouk, provides an updated look at Firdau's plant typology, expanding on the role of manufacturing plants in global networks. The researchers explain that global manufacturing networks are becoming more complex, and plants now have to serve both production needs and strategic goals like cost efficiency and market access. Ching and Farouk update Firdau's model, classifying plants based on their capabilities and location. The study uses data from the 6th International Manufacturing Strategy Survey, IMSS CSCS, collected between June 2013 and June 2014. The final sample consists of 606 plants that identify as part of a manufacturing network from sectors like electronics, metal products, and transport equipment. The plant roles are assessed based on Firdau's two primary dimensions. 1. Site competence includes production, supply chain, and development-related competencies. 2. Location advantage considers access to low-cost resources, proximity to markets, and access to skills and knowledge. Strategic differentiation in management practices. Plants with greater strategic responsibilities, e.g., start plants, have higher autonomy in decision-making, whereas plants with operational roles, e.g., replaceable plants, show reduced autonomy and less engagement in interplant coordination. Integration needs based on plant role. Different plant roles have varying levels of integration needs. Start and expert plants tend to be more integrated with internal functions, like development and purchasing, as well as external partners, customers and suppliers, to enhance their strategic role. Empirical validation of Firdau's typology. The new taxonomy builds on Firdau's model, showing that while some parts still apply, it doesn't fully fit today's global manufacturing networks. It introduces more complex ways to classify plant roles based on their skills and location advantages. The conclusion of the article is that Firdau's original model of plant roles needs updating to reflect the complexity of modern manufacturing networks. The study provides a new framework with 4 clear plant roles: start plant, old school plant, expert plant, and replaceable plant. Application to PT Semen Indonesia, TBK, Persero. As Indonesia's largest cement producer, Semen Indonesia operates multiple plants in different regions, primarily focused on production, but some plants might benefit from more specialization. The types of plants are STAR, high-performing plants in key locations like SIGS Rembang; old school, older, reliable plants like SIGS Gresik; expert, specialized plants with unique capabilities like SIGS Tuban; replaceable, older, less efficient plants that could be replaced. By categorizing plants, SIG can improve operations, optimize production, and manage resources and costs better. This approach also helps plan future investments, like upgrading old plants or building new ones. Capacity planning concepts. Reference: Performance Assessment Process Model for International Manufacturing Networks, by Silas Costa Ferreira Jr., Afonso Carlos Correa Fleury, 2018 study case. PT BYD Motor Indonesia. In today's globalized economy, multinational companies, MNCs, often rely on international manufacturing networks, IMNs, to maintain and extend their competitive edge. An IMN consists of interconnected factories spread across different countries, which need to operate cohesively to support the company's strategic goals. However, managing the performance of such a dispersed network is complex, requiring a structured approach to evaluate how each component contributes to the network's overall objectives. In response to this challenge, Silas Costa Ferreira Jr. and Afonso Carlos Correa Fleury developed a performance assessment model tailored to IMNs, as outlined in their 2018 paper, Performance Assessment Process Model for International Manufacturing Networks. Their model addresses the need for systematic performance assessment of IMNs by focusing on strategic alignment, operational metrics, and feedback processes within the network. This model can help MNCs gauge the effectiveness of their network in achieving goals related to cost efficiency, flexibility, and innovation, key competitive dimensions in international markets. By examining Tesla's approach to capacity planning in its manufacturing network as an example, we can see how this model can be applied in practice to achieve strategic alignment across geographically distributed factories. The IMN performance assessment model developed by Costa Ferreira Jr. and Fleury is designed to evaluate multinational manufacturing networks across several performance. These dimensions, primarily cost, flexibility, and innovation, reflect the strategic priorities commonly held by MNCs. The model comprises 3 key steps: configuration and coordination. First, the model analyzes the configuration, geographic dispersion and factory roles, and coordination, governance and operations integration of an IMN. Factories may have varied functions, such as production, regional distribution, or research and development, that are tailored to the markets they serve. Goal setting and data collection. The assessment process involves setting key performance indicators, KPIs, at the corporate level, then disaggregating these goals for individual factories based on their roles within the IMN. These KPIs, often linked to cost efficiency, flexibility, and innovation, help measure how effectively each factory fulfills its mission. Feedback and adjustment. The model emphasizes the importance of using performance feedback to drive continuous improvement within the IMN. Through regular comparison of real versus goal-based performance, MNCs can detect misalignments and make adjustments to keep the network aligned with broader strategic objectives. This model provides a structured, flexible framework, enabling MNCs to adapt their performance assessment based on the type of manufacturing network in place, which can range from a globally coordinated model to a more decentralized, regionally uncoordinated one. To examine how PT-BYD Motor Indonesia might implement capacity planning concepts in line with Costa Ferreira Jr. and Fleury's model, we could consider the company's actions in configuring its manufacturing network, setting operational goals, and applying performance feedback to adjust production. Following the article's theory, PT-BYD Motor Indonesia would likely align its IMN capacity planning with several strategies. 1. Strategic network configuration and coordination. BYD Indonesia may configure its network by establishing factories or partnerships in locations that align with the demands of Southeast Asia and the broader Asia-Pacific market. Each site could serve a specific role, such as production, assembly, or R&D, depending on the cost structure, logistics, and the regional market's demands. Coordination across these factories would be centralized, yet allow for regional adjustments, promoting cost efficiency and flexibility in response to changing market demands. 2. Flexibility in production volume and mix. To meet fluctuating demands, BYD might implement flexible production systems within each factory, allowing it to shift between electric vehicle models or adjust volumes based on real-time demand forecasts. This flexibility helps the company respond swiftly to trends like the increase in electric vehicle adoption in Indonesia. 3. Innovation transfer and feedback mechanisms. BYD could use feedback mechanisms to monitor performance metrics, enabling real-time adjustments across its network. For example, technological innovations from the headquarters or another region could be transferred quickly to the Indonesian operation, enhancing efficiency and product offerings. This feedback would also help BYD Indonesia make timely adjustments in capacity or technology upgrades to maintain competitiveness. 4. Cost efficiency through localized manufacturing. Building factories closer to key markets reduces costs associated with imports and transportation. BYD Indonesia might prioritize this localization as part of its IMN configuration, supporting both competitive pricing and compliance with local regulations on sustainability and labor. By following these capacity planning strategies, PT BYD Motor Indonesia would be better equipped to navigate dynamic market conditions, enhance operational resilience, and optimize its manufacturing network's alignment with corporate strategy, as suggested by Costa Ferreira, etc.
My name is Muhammad Dimas Arbi Setyawan, and I want to present a framework for capacity and operations planning in services organizations employing workers with intellectual disabilities, referencing from a journal entitled A Capacity Management Model in Service Industries by B. Adenso Diaz and Pilar González Torre can be seen in Specialisterne, a Danish social enterprise company. Specialisterne employs individuals with autism and intellectual disabilities to provide high-quality data and IT services, using a unique capacity management framework to meet both client demands and the needs of their neurodiverse workforce. Here's a breakdown of how Specialisterne applies each point from the journal's framework. 1. Capacity and skill-based workforce planning. Specialisterne focuses on understanding the specific skills and working capacities of each employee. The company assesses individual abilities and adapts tasks to match the strengths of each worker. Similar to the framework proposed in the journal, Specialisterne recognizes the unique skill sets of neurodiverse employees, assigning them to roles that leverage their detail-oriented capabilities, such as software testing and data analysis. 2. Balancing client requirements with employee abilities. The framework in the journal emphasizes aligning client expectations with the diverse capabilities of workers. Specialisterne works closely with clients to ensure that project goals are realistic and can be met without pressuring employees beyond their capacities. This includes educating clients on the benefits of employing neurodiverse teams and setting achievable timelines that respect the employees' working styles, ensuring both high-quality service delivery and employee well-being. 3. Training and development for continuous improvement. Similar to the training focus described in the framework, Specialisterne provides continuous skill development tailored to individual employees. Training includes technical skills for IT tasks, as well as social and communication skills, which are valuable in workplace interactions. This dual focus on technical and interpersonal training supports Specialisterne's long-term goal of helping employees integrate and thrive in their roles. 4. Operational flexibility to meet workforce needs. In line with the framework's emphasis on flexibility, Specialisterne maintains an adaptable work environment. This includes flexible work hours, sensory-friendly office spaces, and opportunities for remote work. The operational setup is designed to accommodate any special needs employees might have, thus fostering an inclusive and supportive workplace. 5. Prioritizing social impact. Alongside financial goals, Specialisterne embodies the social mission highlighted in the ISOSOSITOS framework by focusing on creating employment opportunities for individuals with disabilities, thus promoting social inclusion. This mission drives the organization's operational planning and client engagements, emphasizing that while profitability is important, the primary goal is meaningful employment and empowerment for individuals with intellectual and developmental disabilities. By applying a structure similar to the journal's framework, Specialisterne successfully meets business objectives while supporting and empowering a neurodiverse workforce. This approach serves as a model for other organizations seeking to implement inclusive practices that benefit both the organization and employees with intellectual disabilities. By applying a structure similar to the journal's framework, Specialisterne successfully meets business objectives while supporting and empowering a neurodiverse workforce. This approach serves as a model for other organizations seeking to implement inclusive practices that benefit. That is all from us. This concludes our overview of real-world examples of companies implementing strategic capacity management, including aspects of operational capacity management, capacity planning concepts, and service capacity planning. Thank you.